My name's Alison Griffiths. My maternal grandmother died of breast cancer before she was 50. Her daughter, my auntie, sadly she died by about 47, 48. My mum lost her battle when she was 50. And then sadly my brother Kevin died at the age of 39. And then about 18 months after that, after Kevin died, I was diagnosed with breast cancer and I was 37. But fortunately, 6 years on, I'm still here.
Breast cancer is the commonest cancer in women, particularly in the Western world. The lifetime risk, that's the risk to 80 years of age of someone getting breast cancer in Western Europe and North America, is somewhere between 1 in 8 and 1 in 12.
Breast cancer occurs when the cells that make up the breast tissue start to divide rapidly and form lumps, which can then invade neighbouring cells. An increased risk of breast cancer can be inherited, but most cases are a complex mix of genetic and environmental factors. Professor Gareth Evans is a consultant in clinical genetics and world-renowned expert on breast cancer.
Breast cancer is a complex disease. It's not simply one switch going and off you have with a cancer. It's a real mix between your genetic makeup, your environment, and your other risk factors, particularly hormone risk factors when you have your children, etc.
Inherited forms of breast cancer primarily occur when there are faults in two main types of genes: tumour suppressor genes and oncogenes.
The tumour suppressor gene, if you imagine that's a bit like the brakes on a car, you've got two sets of brakes, and as long as one is still working, that's still stopping the car. Then you get something called an oncogene, and if that's switched on, it's like the accelerator pedal. So the accelerator pedal gets stuck on. And a combination of losing these tumour suppressor genes and switching on oncogenes causes a cancer to occur.
Two well-known tumour suppressor genes are BRCA1 and 2, located on chromosomes 17 and 13. They are known as high-risk genes, and about 5% of all breast cancers are thought to arise from mutations in BRCA1 and 2. Families with a strong history of breast cancer are often tested for these gene faults.
When we were first offered the genetic test, I think the specialists were 99% certain that they were looking for BRCA2 because of the male breast cancer link.
If a family had 4 or more relatives with breast cancer, one of which was in a man, that 80% of those families had a fault in BRCA2, 15% in BRCA1, and 5% were probably due to something else. Well, Alison's family is in the 5% that is probably due to something else. So we need to find that something else to come up with the answer for Alison's family.
Faced with inconclusive genetic tests, but such a strong family history, Ian Bentley, Alison's other brother, felt he had no option but to have preventative surgery.
The procedure I had done was a bilateral mastectomy, which is both breast tissues, both nipple tissues removed. I didn't have to have the lymph nodes removed from under the arms because it was a preventative procedure. If they'd have then found something, they'd have gone back in and taken lymph nodes out. There's nothing there. You can't even see the scars now. And you can't really notice that there's no nipple there. So I don't think I need to have reconstructive surgery.
So for us as a family, it's really frustrating being aware that there's a possible link with our family to a faulty gene. And being the mother of 2 children, I had hoped that by the time they were the age they are now, which is 18 and 20, you know, there would be a test available for them to tell them definitively whether they've inherited the gene or not.
I would want to know for sure and then do something about it as soon as possible so that I didn't actually have to go through what Mum went through.
Yeah, I'd want to. I would like to know, but I find it a bit daunting and like to know at such a young age, and don't want it to sort of rule your life.
girls are young and healthy, and while they aren't thinking about taking measures as drastic as their uncle, breast cancer still plays on their minds.
I worry about it a lot, but then I've kind of got over the fact that, like, I think
it's more probable, isn't it? Yeah.
that one of us will get it, or possibly both of us, which would be very unfortunate. But I don't know. Like, yeah, you do worry about it, but then you do have to just sort of think you don't want it to
rule your life. Yeah, just carry on with everything.
Yeah.
Be positive.
Since the identification of BRCA1 and 2, a number of other high-risk genes have been identified. The next challenge is to identify the lower-risk genetic factors which contribute to a huge number of breast cancer cases. But it's only since the arrival of genome-wide association studies that this has been possible. Although our genomes are virtually identical, there are very small sections of DNA located all over our genome that are different. Genome-wide association studies scan these small sections of DNA in people both with and without the disease. They then look for differences in these two groups to see if any genetic change can be associated with the disease.
These are huge studies based on thousands of patients with breast cancer and controls who haven't got breast cancer, and they're comparing the genetic makeup of factors which are extremely common. And what they're looking for is something that reproducibly is associated either with a reduction in risk or an increase in risk. And rather than just doing one study and saying, hey, we've got all the answers, you then have to validate all of that.
Because the genome-wide association studies are looking at so many variants across the genome and in so many people, the results need to be repeated with many different sample sets. When you're looking for a small increase in risk, you need a large sample to make sure the associations aren't happening by chance. For breast cancer so far, they have found 18 new genetic risk factors.
More and more of the cancers now, we've got validated genetic factors identified by genome-wide association studies that are real players in the causation of breast cancer and other cancers. The more and more of the pie that we're able to identify, the more likely it is that we'll have answers for people like Alison, who has a very strong family history, but yet a family history that we haven't shown is due to any of the known high-risk genes.
With complex diseases such as cancer, lifestyle and environmental risk factors often play as important a role as genetics. Currently, doctors use known breast cancer risk factors such as BMI, age at first pregnancy, and breast tissue density to help calculate an individual's risk of developing cancer over their lifetime. In a high-risk family such as Alison's, these risk factors can be very important.
Just to show you how even one risk factor can substantially alter this, if we say that she actually had her first pregnancy at 35, which we now know more and more women are delaying their first pregnancy, that's one of the reasons why breast cancer is becoming more common, then instead of a risk of 18.5%, her risk has now gone up to 29.5% with that family history. Now, if we then add in that she's got a sister with breast cancer, very, very young, her risk actually goes up to 37% in her lifetime based on that, and she's now got a significant chance of having faults in either BRCA1 or BRCA2.
Risk prediction software like this works very well, but Gareth Evans is heading up a new large-scale study of 60,000 women and is hoping to improve on the current risk predicting tools. In the UK, women from the age of 47 are offered regular mammograms to screen their breasts for early signs of cancer. But by incorporating all the known risk factors and information from the genome-wide association studies, it is hoped they can target the screening programs to those at most risk.
We hope that this work is the beginning of really targeting not just people with a family history, but the entire population to see if we can pick up more cancers early, but not only that, hopefully prevent more cancers occurring.
Genome-wide association studies and other large-scale research projects like biobanks, which collect and store DNA samples and medical records from people, raise a number of ethical questions. Professor Michael Rice, a bioethicist at the Institute of Education in London, has spent much of his time exploring these issues.
One of the ethical issues that arises about biobanks in general is what should you do if you find that some of the individuals who've given material that sits in the biobank are themselves now particularly likely to be developing some sort of a disease unless they get treatment. Now, it's quite early in the history of biobanks, but one could imagine two main sorts. In one sort, all the information given is anonymized, and there is no way of the biobank controllers going back to individuals. That's got certain advantages as well, because it means there's no way that information about particular individuals could be fed back to unwanted third parties, such as insurance companies. But the other sort of biobank, logically, would be one where individuals might even choose to participate in them precisely because they had some sort of an assurance that if there was some relevant information for themselves, somebody in control of the biobank, via a doctor, nurse or counsellor, would get back to them and offer to share the information with them.
Although it's still early days, genomic research undoubtedly has a huge part to play in the future of medicine and healthcare.
It's not the case, for example, that you or I are going in the next year or two to go to our GP with a readout of our own genome, our own genetic sequence, and have a different treatment as a result of it. But it is perfectly possible to imagine in as little as 10, certainly 20 years, that we will see far more personalised medical preventative treatment and treatment of disorders as a result of today's biobanks.
While Alison has made a full recovery, it's her daughters and their children that are most likely to benefit from this new genetic medicine.
Your survival of early diagnosis of breast cancer is probably 85%, if not higher now. And that's purely down to knowledge, awareness, early, intervention, early diagnosis, improvements in treatments, all this wonderful stuff that's gone on over the last sort of 20 years.
This research, together with all the research around the world, is likely eventually to identify what's caused the problem in Alison's family, so that we can give Alison and her relatives, her daughters, a more accurate idea about, are they at increased risk? When is that risk? What can they do about that risk?
The eureka moment for me, and I suppose in a way, was my diagnosis, was, get out there, get on with your life, live your life, do what you can to survive. And it's funny, since being ill, I've done so much more. I've learnt to ride, I've learnt to ski, I've started running, doing all sorts of various different things, just getting on with my life, really, and living it to my very best ability.